Hello and welcome back to Polytudes. Today we are going to be building an ocean shader with shoreline depth and some other sweet bits included. I should probably clarify that this is not using Unity's shader graph. I will certainly do an update for that when shader graph updates allow me to. But that said, I'd basically just be porting over the knowledge that I'm about to bestow upon you now. So even if you're 100% into shader graph, this tutorial will still benefit you. I mean, even shader tutorials using the Unreal Engine would do the same. It's all the same stuff pretty much. So moving on, future me will put a time on the screen now for you to skip through if you want to just jump right into the tutorial. Thanks, future me. But current me is going to spend a minute or two covering what this shader actually does and what it is you'll be learning. So just to run through what this shader does real quick. One of the biggest points for me is that it's fully tileable, meaning no seams, but it's also not just a clone of each water plane, so you can get a lot of mileage out of this. As you can see here, new ocean plane, snapped into place, no seams. And in my opinion, no visible repetition either, so pretty sweet. Of course, we have edge detection with a tiled foam texture. It's probably a bit small here, but we can always tweak that. And I'm using the same texture for that as I do with the sea foam itself, which is always moving around and being masked out, so it's never quite the same, which is always nice. It means you can stare out on this water and never quite be able to tell where the repetition exists, unless you look for it, I suppose, but you know what they say, if you go looking for trouble, you'll find it, so please don't look for my repetition. We've also got depth, so you can have things super clear or super murky, and you may have noticed the refraction happening under the water here too, and so that's based on the depth, which limits the weird refraction issues you may have already seen in other games. It doesn't completely fix it, and I'll explain more about that as we build it, but it's a good compromise considering there's no manual coding involved here. We've also got the ability to create some waves and adjust the speeds of those too. These may not be the most realistic waves in the world, but the method is pretty solid, so you should be able to play about and experiment with it yourself once you know how. And if anyone watching happens to know how to make Gerstner waves using only node-based shader things, then I am all ears. If anyone also knows how to pronounce Gerstner, then that is also of interest to me. It's probably worth mentioning that my waves are tied in with tessellation. So right off the bat, we've got some tessellation based on distance, meaning water that's further away won't need as much geometry. And Amplify actually make this super simple, as there's literally a single node for it. I will discuss how to do this manually though, so don't worry if you're not using Amplify. And on top of that, I've hooked it into the wave height itself, so calm waters won't require a boatload of triangles, but as things get intense, then it creates the geometry as needed. Then there's also the normal map panning, pretty standard stuff. You can adjust intensity and speeds. This affects the overall glimmer of the water, but also the refraction. And so lastly, only because I know people will ask, we're not going to be doing any sort of interaction here, like floating objects on the water's surface. That's mostly a code or scripting job, and since I don't teach that, I won't teach that. But there's plenty of buoyancy scripts and plugins on the asset store if that floats your boat. We're also not doing anything underwater. I do have my water surface as two-sided, and from here you could set triggers so that if you enter the water, then the lighting changes, fog is introduced, some post-process effects can be enabled, etc. But yeah, again, I'm not going to be covering that. This tutorial is just for the water surface as you see here. So that about wraps it up, I think. Not sure if I've missed anything or not, but it doesn't matter too much because we're going to build this entire thing right now. This tutorial will likely be in separate parts, but I'll try my best to keep it condensed and informative. So, alright, let's do it. Okay, so first things first, as always, we'll create a new Amplify shader. We'll create a surface shader. And then we'll just give it some names. And then I'm just going to right click it and create a material, and that way it propagates correctly. Also should have committed that before doing that, so now if I remove this, now if I do it, we'll actually give it the correct name as well. So there we go. And I'm going to select all of the waters in this scene, so we can say goodbye to the previous water, and I'm going to replace it with this new material. So yeah, back to basics. So yeah, the first thing that I'm going to tackle today will be the actual waves, and then provided that we have enough time, we'll kind of move into some edge stuff and some normal stuff. But yeah, anyway, for my waves, I am relying on a noise generator. I'll just get that out. And just as a sort of a quick example, I'll feed some UV coordinates into there, just give it some random stuff, and I'll stick that into the debug so we can kind of like watch what happens kind of as we go. And so obviously there's a couple things that's wrong with this. One, you know, it's not tiling. Two, it's not moving. Three, it's not at all remotely related to the shape of waves. So those are the three things that we need to kind of fix with this, but this is our starting point at least. So what we can do first of all is we'll deal with the panning. So we'll get ourselves a panner node, get that in there, and now we want some nodes for like the speed and the time. And the speed in this case will actually be the direction. So let's just say, sorry, not a vector 1, we want a vector 2 because it's x and y. So we can specify basically which way it moves on the x or the y, you know, minus or plus. For the time, let's just get ourselves a time node, and we'll multiply this by a vector 1, and this will be our, we'll call it wave speed. Actually, this one I'll call wave direction. I won't make this a property though. You can if you want. I'm just not going to. My wave speed, however, will definitely be a property. We'll give it a default value of say 1, and then put that into time. And now you can see nothing's moving because we haven't specified which way we want it to move. So if we want it on the x, it will move on the x. If we want it on the y, it'll move on the y. So for now, let's just leave it on the x. And this is already hooked up, so if I just hit this, so we can see that it's panning. Great, that's one of the problems solved, but still, yeah, we got some seams and it still doesn't look like waves. So let's basically, we can fix two of these issues in kind of one go by using world space UVs, and within there we'll also tweak the actual kind of scale of these. And what I mean by that is basically if I were to come here on the tiling, and I'm not really sure which one of these it will be, but I guess not that one. If I just say 5 and 1, you know, something like that. So basically the idea here that we will do is basically just stretch out this noise so that it looks more like waves. So yeah, let's just go ahead and do that. So let's get ourselves some world space UVs first. So we're going to need a world position node, and we're going to append the x and the z. And this will basically just sort of like project your UVs along the x and the z axis. And I know I interchange z and z all the time. I can't help it. I watch too much American TV. And what I'm going to do is actually I'm going to get down a register node just by holding the R key there. And I'm just going to call this, I don't know, maybe like wave, wait, no, I'm just call this, no, world space tile. And the reason I'm doing that is we're going to kind of use the world space UVs a lot. So at least I have those there. And yeah, so for now, I mean, let's just comment this, can't speak today. And I'll just say world space UVs. And so this can basically just exist anywhere, and then we'll get the reference that we've made. So I'll hit G to get, and then we'll choose world space tile. I guess that was what I called it. Yeah, okay, makes sense. And what we're going to do is actually going to multiply this by the wave. No, sorry, not any of this stuff. Not yet. I'm kind of skipping too far ahead, so I should really just slow down and collect my thoughts. This one is actually going to be the wave stretch. So again, it's going to be a vector 2, and we'll put that into there. For now, let's leave it at 1 and 1 because we probably want to be able to test this before kind of, you know, applying it basically, because there's no need for this to be a property, but I will make it a property temporarily just to kind of tweak the values. So yeah, let's multiply this, and then what we can actually do, this is what I was going to do before. Oh no, yeah, I haven't created it yet, so sorry about that. This is going to be the wave tile, so this will, if I can spell, this will actually be our tiling, so put that as a default of 1, stick that in there. And now basically we can just drop the UV coordinates that we had before. And yeah, for now what I'm just going to do is just hook this straight into the UVs. You can see already things have changed. In fact, I think it kind of went the other way. So if I were to hit that, okay, yeah, it has. So obviously it's messed with the the tile scale, and it's flipped the way that it moves. But the tiling, you know, like the seams are gone. So yeah, wave direction, we probably want this to be -1, so it's actually coming in toward our coast. That'll do. And now, yeah, now we kind of want to tweak, let's actually select the right one. We want to tweak the actual, the value of the waves. So they're going to need to be like a lot smaller. Wouldn't want to go like 0 on the Y because it might just create these like super straight lines, but this is going to be like a pretty low number. Maybe even something like that could be okay. Yeah, that could work. And then we also have, you know, the tiles, so we can specify basically how many of them there would be. But that depending on what kind of style that you're after, you know, I kind of leave this up to you. So for me though, see if that is a 1. Okay, I'm happy with that. So what I'm going to do is I'm going to come back to this vector 0, and I'm just going to put in these values as the defaults. And so this was 0.01, and now that can just be a constant. I mean, if you wanted to keep it as a property and then just like change it to, you know, whatever you wanted, then that's fine. But for me, I'm okay with that. So okay, that's kind of okay for the wave shape, but what we're going to do is we're going to need to actually make it offset the actual vert. So let's get this out of the debug and let's put it into local vertex offset and also into emission, so we can kind of see what's going on. Okay, so you see here, pretty crazy stuff. Let me just actually no, sorry, get down to float 1. I just call this tessellation. Basically, I think we need to be looking at a lot more geometry to kind of see what's going on here. So I'll hook that into there, give it a default value of 8 or so. And if I were to just hit apply now on this, it won't do anything because it's defaulted me to the shader model 3. But you want to be, I think, at least 4.6 for the tessellation to work. So I'll just hit that. Okay, so now we probably have enough geometry, but you can see that there's some other weird stuff going on. Okay, yeah, I mean, we have a lot of geometry, but this is offsetting kind of like in both the Y and maybe the Z, I don't know. Either way, it's going in 2 ways, which is not what we want. So let's put that back to shaded. Pretty quick fix though. Let's get a vector 3, and this will basically just be I don't know, wave up. We don't need to make this a property. You can if you want. It basically just specifies which direction your verts will move in. And we can just kind of multiply this. In fact, just for now, let's kind of just keep it as is. And we'll specify 1 on the Y because that's the way that we want it to move. We want it to go up on the Y. So if I feed that into local vertex offset, you can see that now it has actually made those waves. But yeah, they're pretty boring. You know, missing a lot of stuff. There's no ebb and flow. It's all kind of samey. So we can look into fixing that. First of all, because basically, I mean, I'm planning ahead. I know that I'm going to need these UVs again. So this was basically, if you remember, the end of the world space UVs. So then we had this, and now I've created, you know, these other nodes with the stretched water tile, or the wave tile, and then the actual tiling amount for it. So I'm going to create another register here, and I'm just going to call this one actually like wave tile UV. And then what I can do is actually just tidy this up a bit and stick that there because I'm going to need it again. So I can kind of just get that a bit out of the way. And so from here, let's copy this panner and also the other noise, because basically to create that ebb and flow, you might be tempted to kind of throw down like a sign time, so it kind of just like fades in and out. But then, I don't know, it still looks a bit strange to me. So the solution that I kind of came up with is what I'm going to do is basically just use the same waves that we already have, but I'm going to like scale them down, and then they'll basically come across the whole thing a lot quicker. This will make sense in a second. So for the actual speed, the speed can stay the same, and so the UV's direction will also stay the same. But what I want to do is I'm going to drop down a multiply node, put that there, and I'm going to reduce this maybe like down to like 0.1 or something. Like I want it to be it will scale it down, but it will be larger, if that makes sense. Either way, I mean, you'll see what will happen. So it's getting a bit messy already, isn't it? So what I can do here is I'll just add these two together. I'll ignore the wave up for now, and I'll just stick this into the emission. Okay, so the tiling is kind of crazy, and the speed is also kind of crazy. So let's just try and fix that up. Okay, yeah, something's gone a little bit wrong. Okay, yeah, I've accidentally given this the same UVs. That was why I guess it appeared all strange. So yeah, I apologize for that. I'm trying to make this sort of concise and informative, but I keep making those weird mistakes. So yeah, let's get the wave tile. And now, so yeah. Oh, I liked how I made this whole thing, but because I was going to use it again, but then I didn't. So this is actually the I've got the reference of the wave tile UV. So I'm going to do that again, so I can actually clean this up a bit. So if I'd have done this first, we wouldn't have ran into this mistake, because I accidentally put this multiply into both of them. So yeah, let's just get that in there. Okay, and so now maybe it's a little bit more obvious what's happening, although probably still a little bit difficult to tell. But there's sort of like a secondary mask that's coming through, and it's causing like a change of the initial waves, which is sort of a more ideal version of that ebb and flow. I'm wondering though if perhaps we should go back to our wave, yeah, the UVs here. So the wave, I'll call this wave stretch. Maybe. I'm gonna just play about with these numbers again, see if I can get something a little bit better. I'll be back when, or if I even decide to change them. Okay, so yeah, I've just ended up with these numbers instead, so 0.15 and 0.02. It's not too much different than what it was, so that probably wasn't necessary in the slightest, but there we go. So yeah, it will have this other kind of wave kind of run through the whole thing, which kind of affects all the other waves, which to my mind looks a lot better than kind of like sticking a sine time on them to try and like fade them in and out. So yeah, that's that. And so what we can do from this point is actually start hooking this up into the vertex offset, and let's actually kind of maybe think about tidying some of this stuff up. So we've got the world space UVs, we'll keep over there. This is going to be this is all of our, basically after the world space UVs we have our wave tiling, which is all of this happening down here. Might as well unhook this for now, because I think basically this is just a wave pattern, which we're going to need later. So yeah, for now I'm going to get another reference, and I'm just going to call this wave pattern. Stick that in that just as a register, but we won't actually use it, because what we're going to do instead is, because we've got this added in here, I'm basically just going to throw this up so we can actually control the scale of the waves sort of independently of all of this. So we already have the direction that we want this to go in, so we'll just actually multiply this by vector 1, and this will be our wave height. Give that like a default of 1, I suppose, which will probably be quite big, but that's fine. And then what we can do is just multiply this again, but we're going to use the combined pattern that we have down here. So it's, you know, it's pretty sort of neat and tidy, because this is basically just where we'll control the height, and then this all of this other stuff is the pattern itself. So we can throw off another register here. We'll actually just call this wave height, because this one actually contains the height information, whereas this is just the the black and white grayscale. So yeah, let's grab this. Let's just grab all of this actually. Not you. You can go back there. So yeah, from here we'll get and we'll grab our wave height. And we'll stick that into the local vertex offset. And then let's have a look at that. Okay, so yeah, so I forgot my color, but I can just stick that in just as an example. So yeah, you can kind of see what's happening. I forgot to make my wave height a property, so I could just do that now. Okay, yeah, so now we can control basically the height of the waves, so you can have them, you know, basically be pretty much nil, which basically means, you know, there's not enough power there for it to like lift up the verts. And then yeah, obviously you can kind of go as crazy with that as you want, but I don't recommend too crazy. And then the tiling amount, which will just basically make the waves larger or smaller. And then the speed of them, so you know, you can have really fast ones or not. Yeah, so that's pretty cool. And this is kind of like the foundation for a lot of other stuff. So I'll take this, comment these. Oh, I'm pressing the C key, by the way, to do that. I'll call this one just wave pattern. So yeah, pretty cool. But yeah, at the moment, if I just take out the emission and then just hit that, it's pretty hard to see what's going on. So quickly, I'm going to do two things. One, just put in a smoothness, maybe default value of about 0.9. Stick that in there. This isn't going to make too much of a difference, but it does kind of help. Yeah, we're just going to get in a normal map, but we're not going to do anything too crazy with it, because running out of time for this part. But we'll basically just say unpack normal map, and we'll throw that into normal. So this will basically just help us see what's happening on the surface of this water a bit better. So I'll just apply that and come here, and I think, I can't remember what it's called, water or something. I will be providing this stuff. So yeah, okay, there's our normal map, and you know, immediately there's like a massive change, which is pretty cool. But yeah, moving on, like before we close out this part, I want to just cover the actual sort of albedo, the like the change in tints. And so what we can do with that is we'll basically get two colors, and we'll call, you know, one of them, say, watercolor. Again, I can't spell. And the other one will be our top color. And make these both properties because we're going to want them exposed. For now, I will just give them just, you know, a sort of random value of whatever I want the water to be. So this one will be that kind of blue, and then I always have the top color just sort of like a slightly lighter. So that'll be fine. And what we're going to do is just loop these together. Boom, and we're going to get the wave pattern, so not the one that we use for the height, but the one that we made here, which is just the black and white pattern. So yeah, let's get that wave pattern, and I can't just stick this right in because it will kind of mess with the colors a bit. In fact, maybe hopefully I can just show you an example. If I just put this straight into the albedo so we can actually see it. I mean, it looks okay, but there's like some, there we go, like some strange darks coming in, and that's just because we need to clamp out the pattern that's coming in, because we're adding two values together, which is fine for our height. We kind of want them to kind of play with each other like that, but for the color we do not. So we want to introduce a clamp in here. That way, you know, if we specify a color, it will remain as that color. And so there we go. I mean, already, you know, it's looking close to the previous one, but yeah. So let's just register this again, just because I like to keep things neat and tidy. So we'll call this albedo, and then we will get albedo, and we'll chuck that down in there, and then this guy basically. Okay, so that was actually pretty quick. So as a little extra bonus, I suppose, what I'm going to do is actually do a little bit of the intersection, like the actual sort of edge foam. And this is going to be pretty straightforward. Like, I won't introduce the textures and stuff yet, but we'll basically just set up the basics, and we'll use a depth fade for this. So yeah, we have this, and I get a vector 1, and this one as a property. This will be the distance. So let's say edge distance. Give it, I don't know, a default of 1, I suppose. That's probably going to be too much, but it'll do. So yeah, stick that into the distance, and then we're going to want to 1 minus this. I could show you what happens if you don't, or you could just take my word for it. And then we're going to multiply it again by another vector 1, but this time this is going to be the actual the strength of it. So we'll call this just edge power, and put that in there. And then we might as well just register this, and we'll just call it edge. Bada bing, bada boom. So now let's say get, and then we'll find our edge, stick that into the emission. And it would probably help if your edge power was a property and had a default value. So there we go. Try that again. Okay, so that's pretty ginormous. So let's tone that down a lot. So edge distance and the edge power. Oh yeah, no. So this is the point where you actually need to disable the cast shadows and receive shadows, because it does not play nicely with the depth fade. So yeah, that's kind of working. There's still one more thing that we obviously need to do. So if you ever see like these crazy blown out colors, it always means that you need to use a clamp. So it's easy to forget, but we'll just stick a clamp in there, and okay, there we go. So that's done it quite nicely. So we have the distance, which will basically just, it'll go down an object, and then the power itself controls obviously the power, but you probably do want that to be a slider, because there's no real need for the edge power to go beyond 1. So yeah, 1 0 1 0. Neat. Yeah, so I'm going to wrap that up for this part of the tutorial, because yeah, I'm going to try and keep these kind of short. But for the next part, we'll probably look into more kind of normal map stuff. We'll actually have like the panning. We'll look into depth, refraction. Basically probably try to just finish the shader. I hope this isn't going to be 3 parts, so we'll see. So that's that for now. It's already looking pretty good, I think, but yeah, we will continue in the next part.